Hello everyone, welcome to the second tutorial of ECI 589 SNA in education. Now, this tutorial is focused on visualization and mainly we'll be discussing the main ideas of chapter 4 on network visualizations of Rollins et al. I think I have my book here, this book. Most of what I do here is covered, or all of what I do here is covered in section 5.1 to 2 of the website, the companion website of the book. Now, I'll throw here and there something that I have experienced when I do data visualization in R. As usual, there's something that I added in our materials for this week, and is VDI Theory Guide. And mainly visualization is a tool for us as researchers to tell a story, to explain, to explore. Is in service of theory, and no one better than us as researchers to show how how theory explains visualizations. Um, when in doubt, also follow the hunch in terms of aesthetics. Sometimes networks are too messy. And if something doesn't look right and it doesn't look like it explains what you want to explain in terms of theory, likely you're right. So feel free to change things. There's no one way, but there's a specific set of guidelines that most people think that are aesthetically okay. Aesthetically okay. I recommend that you visit igraph very often. I'm gonna show you the visualization based on igraph, but the website, the companion website, also has like the same visualization, but using ggplot and the gg network packages. Either one works. It's basically more on what you are used to work. I enjoy using igraph, but I also know that ggplot2 could be very powerful, and I have used both. But I find that for an intro session, igraph will be the most beneficial because you will have used igraph in the previous tutorial. Now, I remember that I used the Pacman package to load my packages. So using the Pacman packages, I'm gonna load all the other packages to prepare my session. For set up the session, we need to load the data. And Rolling Settle have gave us some network data that is stored in this GitHub URL. And we're gonna like load it, and we're gonna call that dataset class edges. Remember that edges is one way to load network data. We also have matrices, and we also have adjacency matrices, but we're gonna use edges today. Then we're gonna load the attribute data that is also in GitHub as a CSV file. And we call it class attributes in this case. You can see that I'm loading and the objects are here on the right side. Now we already have igraph, but just for you to remember, the way that you load only one package is through library igraph. And then what matters here, and I know you already saw that in the previous tutorial, is that we create something that is called an igraph object. We tell igraph that we want to have a graph from a data frame. They have very specific functions, thank God. So specifically, we'll tell it that we use the class edges to be our network, that it is a directed network. In the previous, it's the same data that we use in tutorial 1, and it's about the students and their friendships, and it's boys and girls in the sense that the data set is written. We are not talking about gender in this moment, but more so on these attributes and the vertices, the attributes that we have. When we load it and we see how it looks like, we know that we have 24 nodes or vertices and 77 edges. We know that we have some attributes like gender, the grade that we have, the grade in which they are. I think the grade is like 10 and 12, if I'm not wrong. Race, and if I'm not wrong, is black and white. And weight. The weight of the weight of the edges in this case is not that we're looking at the weight of the students. Now, if you want to plot simply with igraph, you use the very explanatory function plot. Let us see how this one looks like. And most of igraphs plots look like this. Once you start and you tell me that's pretty ugly, and I agree with you, we can change certain things. When you're noticing one of the slides for the class, we should be thinking on things like nodes, node size, vertices. Well, node and vertices size, we need to think about node and vertex color. We need to think about edges and their thickness and whether we can change their color and whether it makes sense to change their color. And also the arrows, whether bigger or smaller arrows make sense. Now we're focused on node color. We could use anything to explain to the pick nodes. But in this case, let us explain a little bit about gender. Actually, I think I didn't highlight that earlier on. Nope, I don't see it. That happens with code. Sometimes it's really easy to find, sometimes it's not that easy to find. Yeah, here it is what I wanted to say. When we want to explore something, it's very important that we think like, what is that we want to explore first? Exploring gender divides in the network. Because we're thinking on gender divides, let us focus on gender. Let us color gender based on whether it's female, and it will be female, it'll be light sky blue. And if it's not female, we will use a navy color. That's where we use an if else function. And we add that data to the calls vector. Once we have the calls vector, let us see if it actually works. And the table function tells us that we have some 16 females that are light sky blue and some 8 males that are navy, and that is according to the 24 vertices that we have. Then we could assign the colors to the vertices that are also known as nodes. With V stands for vertex, and then we use the $sign to say that to the color, we're gonna create that color attribute, and in that color attribute, we want to add the vector calls that we create previously. See, yes, we run it, I run it. And now let us run this one, plot. Yeah, now you can observe that we have some navy nodes and some light sky nodes. We can tell that obviously we have more girls than more females than males. That you might infer that we have 2 males that are a little bit apart from the male group, more embedded in the female group. Let's see. Definitely we have a female that is more isolated, a couple of isolated here. They are called pendants when they have only one edge, and I think it's a beautiful name. It's slightly lonely, but beautiful. Then we have node size. In node size, there's a variety of things you could do with node size, but one of the most popular ones is using one of the network measures to manipulate node size, and the obvious is in degree. Is how many nominations, how many friendships does this person have? And what we do is that we use the degree function that we explored in the previous tutorial in the class net object, igraph object, and we'll look for the in degree, because remember you could have in degree of incoming or out degree or of outgoing, and it makes more sense to do in degree, and we're gonna create a vector that is called index. We did that last time. And what we do simply is that we will add it to the plot. We tell that we still have the same plot, but we want the vertex size to be based on index, the vector that we just create. And we will ask igraph to reduce the margin, to reduce the extra space. That's a pretty usual thing in igraph. It has a lot of space on the margins, which is pretty intense. Like, let us see how it will look like. I'm actually curious how it will look like if we don't do that. It doesn't change much, but still, I think it makes sense to reduce the margin as much as possible. Yeah, by the way, you'll notice that every time I run it, it shows a different organization of the graph, because as we read in the chapter, there is not a specific set of coordinates or where the graph should go. You could assign the coordinates. That's something that you could do, but let's not worry about that just yet. You could set a seed in the, let me see if I can do it. You could use set seed. Yep. Doesn't necessarily, yeah, doesn't, wait, I have an extra E. Yeah, if you set a seed, you let, because R runs on randomness, on random numbers. If you let R know that you want to use 0 as a starting point, it could be anything. It could be 1, 2, 3. Like, don't worry about the seed number, but it will give you exactly the same layout. Sometimes you have to trigger a little bit with that, but that's not necessarily to focus, like an important point to think right now. Let's go with the next one. You could increase the node size, and one way is that you simply tell R, like, look, we have the vertex size, and I want to increase it by 3. And I want to change the name of the color of the label, because we can look at the labels and they are like blue, but it's not that obvious. So we could do that. But now we have this pretty nasty red. I don't like that. So something that you could do is to simplify the graph. And to do so, you could simply tell igraph, I don't want the labels anywhere. I don't want the numbers. And there's something that is not in the book, but once I was in a workshop with one of the developers of igraph, and they are really into deleting or not deleting, but into using white as the margin of the nodes. So I thought it would be interesting to use white. I've been using it ever since then, but it's all up to you. You are the researcher, you are the designer in this case. You could also do something that is edge and arrow manipulation. Mainly what we want to do is to make the graph more legible. One thing that I suggest everybody to do is to reduce the arrow size and as much as possible, because if you come back, you see that they are pretty big. They are even bigger than the nodes themselves. So we can reduce it. And now it looks better. It looks way better, in my opinion. They're perhaps the edges, the arrows are still too dark. So something that you could do is to change the edge color with edge.color function. Now I think that it's looking neater and neater by the moment. One of the many ways that you could manipulate and graph is using pre-established layouts. The layouts, there are plenty of layouts. There's no one layout. There are many, many layouts. You could have like circular layouts, but there's one that is popular. We read it in the book, and is the multidimensional scaling, that it is a procedure that displays a matrix of diag distances in a low dimensional scale. So it means that you are trying to take something that is 3D into 2D, and it's already built in igraph. So you use layout with MDS. And it may look like this. It's all up to you to see whether it makes sense or not. You could also use one that is very popular, that is the Camara Kawaii. What I like of the Camara Kawaii layout is that it has a spring idea. So it means that if nodes are closer, they will bring them closer, like as in a spring sort of sense. But they are farther away, they will make it more far away from each other. That's a little bit redundant, I know, but it's more of a reinforcement sort of idea when you use the Camara Kawaii. Let's see how it looks like. Yep. What do you think? I still think that the Camara Kawaii looks better, or sometimes it seems that they are simply rotating, actually. It's all up to you as a designer and as a researcher to see what it makes sense to your research questions and to your audience. Remember that the whole point of a visualization of networks is that we can explore, but that we can communicate our findings to non-research audiences. Now, one thing that I want you to explore is this. Let me move myself over here. Is the help guide of igraph, because it will give you tons of ideas of what things you could do, what things you could explore better. That the manuals and the documentation is essential whenever you are doing any sort of programming. The documentation is your friend. Read it. Once you become more advanced and you start moving from doing tutorials or perhaps self-paced learning in terms of somebody else's code, you will move more towards reading my documentation itself. And that's when you know that perhaps you're moving from a beginner state to an intermediate state. And finally, there's this person, Cateto is her sort of nickname. Katya Ogianova, she's the boss in network visualization tutorials. Perhaps she might not be the one who is developing the latest network visualization tools, but if you want to learn more about network visualization, go to her website, Katya Ogianova. I believe she's at Rogers. I have taken workshops with her. It's amazing what you can do with her work. She has a lot of tutorials more based on igraph than other um, packages, and she also has tutorials for animations, for dynamic networks, for I don't believe she has for contour plots, but she has for dynamic networks, definitely. So I would most definitely suggest that you go and look at her work. And this is the code walkthrough for the week, and I'll be seeing you in another one.